I mentioned, my name is Chris Rogers. I'm a senior technology evangelist, and we're going to go over replicating and detecting on the Zerto platform. So I mentioned that we do CDP, so continuous data protection. So the best-in-class CDP, and we're using a technology called near synchronous replication, right? So the actual replication piece is near synchronous, and that's taking kind of the best bits from synchronous replication and the best bits from asynchronous, and joining them together, and hopefully leaving the bad bits apart, right? The asynchronous being long gaps between replication windows, and synchronous being those horrible round trip times and all that kind of thing that we get with those metro clusters that we know and sometimes love in some environments. But what does it actually mean? What's the use case, and what's the differentiators we've got here? So we're not scheduling anything. We don't take any snapshots of virtual machines. We don't have any agents installed on the virtual machines as well. I think the agents piece is a real key benefit for us as well, because there's nothing else to attack inside the OS, right? If you've got agents running, there are clues there. If you're looking at, you manage to get into file server, whatever it might be, there's cues for bad actors there and clues to say, these guys are running this backup software because I can see the agent running on their OSs, or I know there's a vulnerability in this certain version of this agent, etc., I can go after. We have no agents inside the OSs to worry about, and that means we have a wide range of support for operating systems as well. But when I mean no scheduling, we're just replicating the data as quickly as we possibly can. So as you saw from previous slides, RPOs between 5 and 10 seconds is pretty typical for the vast majority of Zerto customers. And because we're not taking any snapshots, we don't have any production impact or virtual machine stunning either. So we don't have to worry about only backing up or only taking copies of data once a day. We can do it as many times as throughout the day, as I said, on that continuous basis with those super low RPOs. And because we are doing those super low RPOs, we are replicating every change that happens inside the virtual machine in near real time. And because we are replicating in near real time, it enables us to do detection in near real time on those blocks that are flowing through our systems as well. I will cover detection in a little more detail, but I wanted to kind of give you an idea of, because we are replicating the data on a near real time basis, we're able to analyze those blocks and those files, those blocks on a near real time basis as well. We're actually inside of the hypervisor is where we replicate the data from. So we're not using any particular storage to replicate data. We're not using anything inside the OS. So it's our own proprietary information and IP that we're using to replicate data. So you can have the hardware and storage of your choice for the software piece of this. And that means we can also then protect on-premise and cloud environments, but also have a one-to-many environment where we can replicate. Let's say it's a virtual machine, a VMware environment, we can replicate that out to up to 3 different locations at the same time as well, giving that ultimate protection. So it doesn't have to be VMware to VMware. It can be VMware to VMware, Hyper-V to AWS as well. So we're strengthening by putting it into multiple different platforms, if you will, as well. Defense in depth. We always talk about, if you get hit with an ESXi attack, well, guess what? We've got a copy in AWS, which is unlikely to get hit with the same.
So, Chris, hey, Chris, Max Mortillaro, I do have a question because you mentioned ESX.
Far away.
So, as you know, VMware, let's say, licensing policies have, heavily impacted how organizations are, redefining their virtualization landscape. So, are you planning to support other alternative options like Nutanix at the moment, or anything else like open source solutions and so on? Or is that under?
It's not under NDA. We haven't got anything to announce in terms of I can't say yes, we're going to go ahead, but we're investigating the landscape. Obviously, it changed really quickly. I think quite suddenly for most people. I don't think most people saw the changes happening as quickly as they did. Obviously, we feared that things might happen, but we actually reintroduced. So at the end of last year, maybe on this security on the field day I did last year, we announced that we were actually deprecating support for Hyper-V because Microsoft are going in a slightly different direction with Azure Stack and their kind of hyper-converged infrastructure, etc. We saw the demand for Hyper-V dropping off because people were moving away to cloud environments, etc. So based upon the things that VMware have done in the last, VMware by Broadcom, I should say, in the last kind of 6 months maybe, we've actually introduced Hyper-V support back into the product. We reversed that decision purely based on the environment, right? As our product manager said, right, the environment 12 months ago meant that the smart decision was to deprecate. that environment changed drastically. So it made sense to U-turn on that and reinvest, because we are seeing those conversations happening right now. Is, hey, VMware have made it difficult for me to continue down the path that I'm on, so I'm looking at alternatives. And on that first slide that I did show, we had that multi-cloud mobility piece. We're really seeing that come into fruition with the Zerto platform as well, by enabling people to migrate to AWS native, Azure native, Hyper-V as well, by doing that, by allowing them to replicate to those platforms. We have a dedicated migration workflow as well, with zero data loss, minimal downtime as well. So we have changed some stuff, and I'd imagine if I was a product manager, I would probably say something very political, like we're investigating. But yeah, I'd imagine it's going to be on our radar, because these conversations are happening, and happening at pace as well, as these renewals start coming through and people are starting to really feel the pain, or maybe not pain, but maybe realizing that it wasn't as easy as it is before, and looking at that, and maybe speeding up those strategies. Maybe they had a cloud strategy over the next 3 to 5 years, and maybe that's going to be now a 1 to 2 year strategy type of thing. So we are seeing that. Yes. Does that answer your question okay?
Yeah, thank you.
This is Krista Maycomber with Futurum Group, and maybe you'll get to this a little bit later in your presentation, but when we talk about detecting ransomware and other cyber attacks, there's obviously many different tools across the infrastructure stack, the application stack, that sort of need to come together to be able to, either detect an attack, prior to its impact, or kind of after it's already exfiltrated the environment, excuse me, or penetrated the environment, I should say. So can you talk a little bit about where Zerto is going to play in from that perspective?
Yeah, I will cover it later on, but as we're asking the question, I can ask it now. We are, unlike some others in the industry, we know what we are. We're a data protection solution, right? We're not trying to rebrand ourselves as a cybersecurity solution and saying, hey, buy Zerto and you don't have to buy any other cybersecurity solutions, right? Incorrect. We all have to work in harmony, right? All these companies that are going to be on Security Field Day, we need to work in harmony together to beat this problem. And as you mentioned, there's going to be technology that helps you stop it before it gets in. There's going to be technology that helps you stop it once it's in. We are firmly in the place of, once the impact has happened, we're going to give you the earliest warning signal that something is happening in your environment. So you still want to stop as much as you can from getting in, obviously, and then you want to try and catch as much stuff before impact as obviously. But if you miss those two things and impact does happen, we are going to be the earliest warning signal that something is wrong in the environment, because something is impacting the data. And that's where we're playing, is in that space. There is, if those two things don't catch whatever is in the environment, we're going to hold up a nice big red flag to you and say, something doesn't look right in the data that we're looking at. You need to investigate now. And it's on this VM, on this disk. So take a look at it. That's firmly where we're playing. We're not saying you don't need intrusion detection and all your antivirus and all the other stuff that you're going to have and all that kind of stuff. We know where we sit. We want to be part of that. I hate using NIST framework, but if you look at recover and respond, we're in the detect piece as well, but we're not fully in that. We're not going to say get rid of everything you have and use us solely. We're in the game of working collaboratively. You might steal a bit of my thunder, but we also have in the detection piece, we built an API first, so you can pull out all that information and put it into whatever systems you're using already, right? It's not an isolated silo of information. We want to be part of an ecosystem that helps you, defend your data against these attacks. It's not just us. It's not just a SIEM or a SOAR or a system or whatever else you've got. It's a combination of everything. You need all of those pieces equally invested, equally up to the right standards, equally working together to try and defend against this threat. Is that okay?
Perfect, thank you.
No problem. So let's look at we know how we're replicating the data. We're doing it using CDP, and then once we've got a copy of the data, we store it in our unique journal. So the journal is just exactly what it says on the tin. It's a point in time copy, but we store our checkpoints in this journal. So you can see here on a traditional backup or an incremental snapshot, we're going to be 24 hours worth of data loss or 4 hours worth of data loss on those particular points in time. With Zerto, we're storing them every 5 to 10 seconds. So you can keep them from anywhere from 1 hour all the way up to 30 days. So in the disaster recovery days, so early on in Zerto, it was very common to find 1 day, 2 day journals, because storage costs money, so we can't just store things forever. We'd love to be able to, but storage does cost money. But as we've started to see Zerto evolve and our customer base evolve and ransomware evolve, we're starting to see journal histories get longer and longer and longer, because the average dwell time, again, I'm going to steal my thunder, but the average dwell time is between 6 and 9 days for ransomware. Usually, obviously, some are longer, some are shorter, but 6 to 9 days is normally what we're seeing. That's from a Mandiant report. So we're anywhere from 1 hour to 30 days. And then we're keeping those checkpoints every 5 to 10 seconds apart. So when something like ransomware or a disaster does hit, we can simply rewind back to a point in time before the impact, before the encryption started, and recover data from a clean point in time. That allows us to minimize the data loss, and that allows us to, hopefully resume operations as if nothing ever happened, right? We know that it's not going to be quite as simple as that, and I am kind of simplifying it a little bit for the point of the slides, but essentially having loads of copies of your data only seconds apart prior to something happening, that gives you total flexibility in when you recover, minimizing the amount of data loss you have. That's essentially what's happening here. And the way we actually protect applications is different as well. We try to be a bit different as that, so if you didn't know. So what we have is a concept of virtual protection groups. Most data protection solutions, especially in a VMware or a VM landscape, uses a VM-centric approach. So we take a backup window and we take an application and we put it into a policy and say, hey, this thing needs to be backed up every once a day, twice a day, choose your policy, whatever it may be. But inside of that, there's no real granularity, no real way to control what happens when. So we've got, a 4-tiered server here, DB, app and web, and file server, right? So that makes up an application. They all need to be together. They all have to be there for it to be working. Otherwise, it's kind of pointless. It's a bit like a car. You can't just have the wheels. You've got to have the whole car for it to go. What happens here? We have an inconsistent recovery experience, because we've got an app server that's out of sync with a web server, that's out of sync with a DB server, that's out of sync with a file server. So we end up having to kind of most likely choose the DB server and work up from there. Maybe redo some log, get everything back into sync. Lots of manual effort. So we have this kind of horrible situation where we're restoring virtual machines using backup, which is absolutely fine. But then we're having to do a load of manual effort and a load of manual tasks and potentially stuff we weren't planning to do, or unplanned, or a little bit unknown. We don't know how long it's going to take to do those tasks. It's not orchestrated. It's not automated. It's not going to be easy to do via machine learning or via a script or anything else like that. Because it's going to be different every single time you do it. Whereas with Zerto, every time we're taking a checkpoint, every 5 to 10 seconds, as I mentioned earlier, we're taking the whole application stack as a single logical entity. So the file server, the DB server, the web server, and the app server in this instance are from exactly the same point in time. So every point in time that we take is from exactly the same point in time. So when we recover the whole application stack as a single cohesive entity. So we don't have to worry about redoing logs and waking up a DBA, because the whole application is in sync from that point in time. And we don't have those staggered backup windows or those replication jobs or those snapshots that are inconsistent in time or anything else like that. Or even worse, that one VM out of the 5 that make up the app didn't snapshot correctly. So we can't use that whole snap for the whole day. So you have to go back 24 hours. Even though we had a 75 or 80% success rate on our backup window, one VM out of the whole stack didn't work. So we can't use that particular backup. So it's a nice cohesive way and a consistent recovery experience for that application.
I do have a question on that.
Yeah, of course.
Does that implies that the application owners or the people managing the infrastructure need to somehow prepare their infrastructure so that you are able to restore it in that way, or is that out of the box? Because I'm assuming here that you need to start, packaging, servers, components together so that you can have a consistent restore.
So inside of the Zerto platform, I can show you it later on in the demo. Not planned, but I can run it through. We have a boot ordering section as well. So when you do the recovering or the recovery task, you can start your DB first, wait period of time, app server, wait period of time, file server, wait period of time, web server, and bring it up that way. So inside of the workflow, we can build that out. Is that what you're asking, or have I missed the question?
No, it's correct, and I get the point with what you say, because it's tied somehow to your kind of DR, recovery workflows, where you're going to structure anyway which application, which groups, what systems you start first, and so on, right? Okay.
Yeah, exactly that. Yeah, and also this is completely logical, right? So they don't have to be sat on the same LUN. They don't have to be sat on the same hosts. They don't have to be sat in the same data stores even, right? It's completely logical from our point of view. So we don't stop VMs moving around and with DRS and all that kind of other stuff that makes it cool. We don't really mind. And even if you have a shared DB server, right? There's no max amount of VMs you can have in a protection group. So even if you had a shared DB server that served two applications, we'll bundle all those apps together, right? And bring up those two apps together. Because likely if they're sharing a database server, they've probably got the same level of like criticality, or they're going to be sharing similar levels of RPO and RTO and SLA, right? Most likely. So bundle those all together and bring them all up as with two apps. It doesn't matter to us. They're completely logical entities, which is nice.
Hi, Shira Rubinov, President of Cybersphere Future Room Group. This is a little bit of a different question, more of a business perspective. You mentioned, yes, certainly. You mentioned numerous times you're the fastest out there. How could you claim you're the fastest out there amongst all your competitors that do something along the same lines or similar to you?
I think maybe if I've claimed to be the fastest, maybe I'm misspoken. But we are the fastest technology out there in terms of what we do. But it's also the amount, how quick you can do things at scale as well. So we're proven over the last 12 years, whatever it is, that our customer base can do. I mean, I didn't even put this slide in, but we've got customers doing, multiple thousand virtual machines with RPOs of seconds. Very rare you can find other data protection vendors who can claim the same and have case studies and customers happy to come and talk to those levels of scale and that level of RPO. So that's what I would say to that. Obviously there's going to be other vendors out there who are going to come on and say, hey, we do it better, we do it quicker, we do it faster. I can only go from what I know and my experience in the field and things like that. That others have come and joined us in the continuous data protection party, and we still have plenty of customers who are running backup providers. The same vendors who are claiming that they're doing the same thing as us, that run those backup providers for their backups and still use Zerto for their CDP.
And do you mind sharing with everyone watching here who may be some of your main competitors out there that you're seeing along, in the competition along the solving for this, and that you're faster than?
I'm not sure if I can say if we're faster. I think HP Legal might kill me if I say that, but I can say who our competitors are, right? So
the main competitors. It's a wide space, certainly.
Yeah, and our competitors do change depending on the use case, right? So if I'm talking traditional disaster recovery, you're talking things like SRM, recover point for virtual machines, those type of things. If you start looking at multi-cloud mobility and those types of things, Azure Site Recovery, Elastic DR service from AWS, those types of things. As you start looking at ransomware recovery, you start looking at your traditional, but VMs, KCDs, rubrics, Commvaults, those types of things, and we all mesh and play in the similar spaces. The one thing I would say is that in most of the other organizations, CDP has always been an add-on, right? So they've launched a backup product that uses snapshots, etc., and there's CDP along the way, and you can use CDP or you don't. CDP's been part of our DNA since day one. We don't do anything else. That's all we do. If you want something different to CDP, you need to look elsewhere. So all the things that I'm mentioning here are all available as part of our CDP platform. Whereas if you look at other vendors in the marketplace, they have ransomware detection and all that kind of things, but it's all based on their backup systems. They're not applying it to their continuous data protection systems as yet. So that's one differentiator I would make.
Okay.
Is that okay?
I'm sure I'm not going to push further here. Thank you.
Perfect.
We could go on for a while, but that's so far so good. Thank you.
Okay, good. Oh, got me sweating. Right. So let's look at the detection landscape. Just to kind of, again, most people are going to know this, but for people who may not know, three main types of detection in our space is going to be signature based, using known signatures, those extension types, etc. Traps or honeypots, logging something when it comes into a safe space or a purpose-built space to say, hey, come and attack this and don't attack my production. And once I know you're in there, I can defend from what you're doing. And then anomaly-based, spotting anomalies in data. So we are in the anomaly section, where we look at data flowing through platform, highlight anomalies, and then tell you when we see something that doesn't look quite right. So where do we fit? So, and I think I've kind of covered this a little bit from an earlier question, but I'll cover it in a little bit more detail. So this is using the revised MITRE ATT&CK framework, which I'm sure most of you have studied and are far more expertise in, and far more expertise than me in most of this area. But typically, initial access happens, and then it's C2, command and control, and then the lateral movement. And then we start looking, and then they start looking for disabling security backup agents. So that, again, another great thing about Zerto, as I mentioned earlier, no agents to look for. Virtual machines don't know they're being replicated by Zerto because it happens inside of the hypervisor. So it's going to be quite difficult for an attacker to know that Zerto is being used to replicate data and protect data in that instance if they get access to an OS. And then in the Mandian M-Trends report, which I absolutely love reading every year, it's so insightful for me. So the medium dwell time, depending on industry and geographies and things, between 5 and 9 days is typically what we see. And then once encryption happens, how do we detect encryption is happening? How do we detect the point of impact? And then how do we know if recovery is needed and what needs recovering, right? That's the piece that we're trying, that's the answer we're trying to give everyone here. It's not about detecting at the initial access phase or when they're moving through the environment. That's all further up the stack than us. That's more dedicated cybersecurity tooling for that. We're here to say once impact has hit, we're going to give you a nice early warning signal. So, as I mentioned earlier, replicating the data every 5 to 15 seconds. As it's flowing through our system, we're detecting suspicious writes as they stream in, and we're flagging those to administrators. Then inside of our journal, we then essentially flag that inside the journal to say, hey, we think something looks wrong. We also send out alerts, and then you can pull them via API and all the other stuff that I mentioned earlier. Pull them into whatever systems you want. So a nice big red alarm goes off and say something doesn't look right. Essentially, what we were trying to do is the first time that you know that something's gone wrong in the environment is hopefully 5 or 10 or 15 seconds after something's gone wrong, not when a user tries to open a file and it's encrypted or when an application goes down, because the likelihood at that point is they've spread pretty wide and pretty far, and it's going to be hard to track down what's happened. The idea is if we can detect it as soon as possible, we can hopefully then minimize your blast radius as well. If we can detect when the impact has occurred, we can then hopefully, get your administrators or your cybersecurity teams or your Tiger teams, whoever it might be in the environment, your partner network, whatever it is, to take action quicker than you would have done before. So minimizing that blast radius as well. And this is just a quick kind of data path slide to show you where we detect in our data path. So virtual machines right through the hypervisor to the storage. As we take a copy out of the hypervisor, we send it to our virtual replication appliance, VRA, and another acronym for you to remember. So essentially, once it's gone into the VRA, it's in our memory, it's in our control at that point on. So at the source site, so this is source, we haven't sent anything across WAN or anything else like that yet. We haven't sent it anywhere to store it. So at the point it's in memory in our system, we're using a few CPU cycles to analyze encrypted blocks or look for encrypted blocks, and we have a selection of algorithms, and then depending on how many algorithms you match upon depends on the level of severity of alarm you get, essentially. So you go from yellow up to red alarm, depending on the amount of algorithms you hit on there. So essentially, once that's happened, we can then send the data across. We send it near synchronously, as I mentioned, 5 to 10 seconds. We store it in the journal from 1 hour up to 30 days. And then as soon as your 1 hour or up to 30 days is gone, we then store that data out into the replica disk, which is essentially the oldest copy of the data we have. So I think the point of this slide I wanted to make sure is that we're detecting before it's even left your site, before it's left anywhere, before it's gone onto secondary storage or before it's been stored, we're detecting essentially pretty much in real time as that write flows through our systems. That's the key differentiator that we have here. We're not waiting for it to be stored and a full backup scan to take place, and it can take hours to potentially scan a large backup set. We're doing it in near real time, every block that flows through, analyzing for encryption and seeing how it goes from there. I'm just going to do a very quick demo of the detection, if that's okay, and then I'll jump into immutability and isolation. So hopefully you can see my environment. Again, only a lab environment, so relatively small, and it is live. So the curse of the live demo may strike, but hopefully not. Hopefully everything goes nice and smooth. So I'll just run you through very quickly kind of the stuff that I've been talking about, just so you can kind of see it in action and see how it kind of plays out in real life. So virtual protection groups, we've got 7 VPGs protecting 10 virtual machines, nearly 100 gig of data, and we can see achieving really good compression rates and average RPO of 4 seconds. What's my virtual estate there? My sites in here, I've only got one site connected, but you can have multiple different sites. As I mentioned, I've got vCenter to vCenter because that's the easiest lab for me to set up. But we can have AWS, Azure, VMware on Google Cloud if you wanted to, Hyper-V, as I mentioned earlier, your choice. And then inside of here, we have our virtual protection groups. And you can see this is a real-time RPO layout you can see here. So, we've got some at 2 seconds, some at 7 seconds, some at 6 seconds. And this is all based on the amount of data that's being written and all the other stuff that's going on. But we essentially replicate the data as soon as we can out of there to the secondary site. And you'll see some that I've got going locally. So essentially almost like a live loop back. So it's replicating back to the local site, and then some going across to my secondary DR site as well. So kind of paint you a picture, if you will. And I've got a selection of virtual machines that are being replicated. So if I just run you through quickly what a VPG does, what does it look like? So again, the idea of Zerto is simplicity. Everything should be nice and easy to do and easy to configure, easy to understand as well. So you don't have to be a complete expert on this to be able to set this up. It should be relatively straightforward for you to do. So you select your type. I want remote DR and continuous. We'll set up a SQL one here. So SQL remote, give it a name, give it a priority, low, medium, high, very self-explanatory. This only really comes into effect when we have contention somewhere, so on storage or network, we obviously prioritize higher traffic, and then a description. Sometimes helpful to have a description when something has hit the fan and you don't know, you have hundreds or thousands of these things, you want to know which one's first, you can have a nice description. And essentially, we have a selection of unprotected VMs we can choose. So guess what, my 3 SQL virtual machines I'm going to have here, copy across to my selected VMs. And for the person who asked the question about boot order, this is where we would set the boot order. So I haven't got any app servers that connect to these at the moment, but I essentially add a group. I then drag my VMs down and I set a delay of 60 seconds, whatever it may be. Then I add another group and I drag it down and I add another 60 seconds, whatever it may be. So that's how we do boot ordering. Very simple, nice drag and drop, nothing particularly complicated. We choose our site. So again, local or remote. I'm going to choose a remote site. We choose either a particular ESXi host in this instance or a cluster. If this was Azure or AWS, you would see your accounts and your everything else in there rather than VMware literature. Choose my data store. I've only got one, but here you get to choose where you're powering up your virtual machines, which data stores you're using. Journal history here, 1 hour, as I mentioned, all the way up to 1 hour, all the way up to 30 days. I'm just going to keep it as an hour just because it's nice and simple. Then we have an RPO alert. So not to be confused with the actual RPO, this is an alert, as it says there, but it's amazing how many people say, I don't want 5 minutes. I'm going to put this at 5 seconds because I want my data 5 seconds. But this is just for alerting purposes. If we see 5-minute RPO for most people in most environments, they'd be very, very happy with 5 minutes. If I see a customer environment with Zerto and they've got an RPO of 5 minutes, I'll get them to log a support case because something isn't quite right. That's the level of difference that we have there. Oh, sorry. And then we also have a test reminder here. So how often do you want to test this plan? How many times a year do you want to test this? We'll send you a little reminder. Oops, I've hit refresh somehow. That's clever. Just run through that real quick. 2 seconds. And here we have our VMs. So these have only got one volume on each. So do we want them thin or thick provisioned, very simply. And then we have a choice of 3 different replication types. So continuous sync, which is CDP, what I've mentioned before, initial sync, and no sync at all. Very self-explanatory. Initial sync only takes an initial copy of data. No sync copies nothing. Continuous is ongoing replication for that disk. And inside of here, we then have a fork in the road. We have our failover live network, which is where do you want your VMs to land when we do a failover? And then we have a failover test network. Where do you want to do in an isolated environment when we're doing testing to not impact production? So away from production workloads. And then which folder do you want them to recover into? And then again, we have continuing down our 2 different forks. So if you want your failover network, here's my VM network. Which IPs do you want to configure? Do you want to configure new IPs, yes or no, static, DHCP, etc.? And then the same option for your failover test network. So if you're going into a bubble network, maybe you want to re-IP the machines, you can do that as part of the orchestration automation plan. And then inside of the extended journal copy, which is essentially how we do immutability for the first piece, we can then take copies from the journal, store them onto secondary storage. And the gentleman asked the question, this is our first layer of immutability, is, hey, you want to store this on Azure, AWS, S3 compatible storage, Scality, etc. Mark them as immutable. Here's how you do it. You do it there. You do daily, weekly, monthly, yearlies, and mark them as immutable in that piece. And I will cover that in a bit more detail. But I want to show you one thing here. Hopefully this works. So I have a file server here with some files in. You can see I've got some backups in here. I've got some PDFs, etc. Hopefully they open fine. It's a little bit slow because it's my lab, but bear with me. But essentially, we got a file server. Obviously, it's simulated. Obviously, it's going to be Edge. It's going to take forever. So we have some files available. And I'm a user, and I'm going to come along, and I'm going to click my application. Unfortunately, my application has been taken over, and now it's encrypted all of my files, right? I don't have a way out. I can't do anything. They're all encrypted. Nope. Okay, fine. Obviously, this is very basic. This isn't probably how it's going to happen in real life, but for demo purposes. So you can see inside of our environment here, we have been alerted. So something it says up here, we have detected abnormal activity with normal encryption behavior on this file server, and it affects these following file volumes as well. So we've only got one VMDK. So essentially, it was a couple of minutes because I couldn't figure out how to get Zoom to move out of my way. But in less than a few minutes, we've got an indication that something was wrong in that environment. Something's abnormal and has triggered an alert in here. So then we can then flag that to whoever we need to flag it to and say, something doesn't look quite right. Let's go and sort this out. Let's go and figure out what we're going to do. So that's essentially, hopefully, what we're going to do is sort out, stop it, maybe, isolate that machine, whatever we're going to do with it, we can take action. We haven't got any automated actions because everything is, when we spoke to customers about this, every single customer had a different answer to what they would do in this situation. So we decided to, hey, you decide what you're going to do with it. We give you the alert and you can then automate based on the alert. You can put it into your Siemens source systems and do whatever you need to do with it, but we're not going to do anything. It's down to you at that point. And if you wanted to, you can just come in here and ignore them and essentially dismiss them and say, hey, that's fine. And once that's done, it's done. So any questions on that before I switch back to slides?
Yeah, I have a question, Chris. This is Tony Afontis. In order to do anomaly detection, you first have to establish some sort of baseline. So how are you establishing the baseline of what that data is? And then is there any kind of software or data that generates false positives, that generates a lot of writes that are encrypted anyways, and something gets flagged as if it was malware, but it's actually just legitimate data?
Yeah, 100%. So on the first point, we have like a learning period. So when you first put Zerto in, it has a learning period to understand what the environment looks like and set baselines. And it's kind of a constant learning period. It does learn from what's happening as well, but we have an initial learning period that we base it on. And your second question, yeah, there will be stuff that triggers stuff. So a customer had this installed and then turned on BitLocker on their machine, right? Guess what? It went from no encryption to everything being encrypted, and we flagged it and said, guess what? Yeah, it's now encrypted. But the customer's like, hey, that is abnormal behavior, right? We're not saying it is ransomware. We are saying that it looks like an abnormal. And again, that's why we're not doing any of those automated actions as well, because we don't want to suddenly shut off Zerto or shut any replication or shut down virtual machines and that kind of stuff, because we're not in the OS, right? We're not scanning it and we're not saying this is 100% a ransomware attack, right? We're saying this looks abnormal, right? If you have a DBA that turns on encryption on the database that wasn't on, it might flag because it looks like abnormal encryption behavior, and we're doing it from a block level, remember? So there's obviously massive positives to having this, and yes, we will throw up some false positives. I'd imagine every single detection software in the world is going to have false positives at some point, but I suppose that's the trade-off, right? And that's kind of what we're playing with. I don't think any of our customers would accept us slowing down the RPO dramatically to kind of like inject something into the OS to look at it more, right? Like that's not where we're playing, right? We're using what we have, the data we have in our existing data path, and saying, how can we give you more information and help put another tool in your armory, essentially, I suppose, to figure out what that is.
So Chris, this is Krista Maycomber again. So is there kind of, are you saying there's a way to maybe set some thresholds for administrators to be able to, you know, kind of say they only want to maybe see some of these alerts or activity if it's above a certain threshold or something of that nature?
So built into the software already, we have like that learning period and that threshold already is it's not customizable by the user, but it's already built into the software essentially.
Sure.
But we, as I mentioned earlier, we do have the amount of algorithms. So we have multiple algorithms, and if you only hit one of them, so if you know maybe you dropped a zip file on there, right?
Mm-hmm.
It's probably not going to go from one zip file because it's going to match a one algorithm, and we're going to say, yeah, but all the rest look fine, so we're not going to flag that to you, right? If you match, so this one here was a yellow warning you would have seen, so that would have matched a more number of them to trigger the warning to say, yeah, it looks like that was there, but it was only a few files, right? So where maybe it didn't match all of them. If it matched, you know, the majority of the algorithms, we then send a red out to say we think we're pretty confident that something massive has happened, right? If you suddenly encrypt a whole VM and it wasn't, we're probably going to throw red because that is every single block on that thing is not encrypted, and now it suddenly is. We're probably going to throw a red, but we have those kind of thresholds built in, if that makes sense. So it's not just we see something weird, flag constantly. We have that level of intelligence to kind of, hopefully we have the level of intelligence that we do to kind of figure out what it is and give our best estimate that something is not right in the environment.
Makes sense.